right, in this video, we're going to learn how to prepare solutions in a lab setting. There are two methods to making solutions in a lab setting, but before we get into that, we need to learn about some terms that you're going to hear often in this video. The first is standard solution. This is a solution that we are trying to make. We are trying to make a solution that has a very specific concentration. It has a known concentration. And standard solutions not only have a known concentration, but they're very exact. They've not been approximated. We've done the calculations to make sure that we know what the concentration of that solution is. The second term that we're going to see a lot is volumetric flask. And this is a very special type of equipment that we use in order to make our standard solutions. And this allows us to be pretty exact with the volume that we are making. So a volumetric flask looks something like this. And you'll notice this very unique shape with this long neck. And there's going to be a line that's going to be close to the top of that neck. And that line is very important because it allows us to be very specific with the volume that we have. So for example, if this is a 500 milliliter volumetric flask, if we fill up to that line, we will get exactly 500 milliliter. There are different sizes of volumetric flasks. You could have really small ones that can fit up to 50 milliliters or bigger ones that could fit up to 1 liter or even 2 liter. Okay, so having said this, let's look at the two methods that we would have to use in order to make standard solutions. So the first is dissolving, in which you're taking a solid and you're dissolving it into water, and knowing the correct amount of solid that we put into that water allows us or gives us the information we need to get a certain concentration. The second is starting with an existing solution. If I want to dilute that existing solution, how much of that do I need to use and what concentration will I end up with? And in fact, we've actually done the calculations for both of these, so we know how to, or you should be able to calculate these already, but we'll run through the calculations again, but we'll put it into the context of doing this procedure in a lab setting. So the first process is dissolving. So this question asks us, prepare a 1.0 liter solution of NaOH with a concentration of 1.5 moles per liter. Now, you might want to ask yourself, when would you use the dissolving process instead of a diluting process? Now, in order for you to do dilution, you need to have an existing solution. In this case, we don't have that. We know what concentration and what volume we want to end up with, but we don't know, or we don't have a solution to begin with. Instead, we know that we want to have the solution of NaOH, and NaOH starts off as a solid. So the question you're really asking yourself is, how much of this solid do I need to use in order to get this particular volume and this particular concentration? So the answer to that is we have to start off by finding the moles. How many moles are going to be there when I make this solution? So if I have 1.5 moles per liter of NaOH, and how can I use that value? How can I use this concentration and volume to solve for the moles of NaOH? How many moles are there going to be in that solution? And all I have to do is I have to use my dimensional analysis or my unit analysis. And if I write it like this, my liters will cancel out, right? So all I would need to do is multiply my concentration by the volume to find the number of moles. So 1.5 times 1 is 1.5. So I know that in this solution, when I make this solution, I'm going to have 1.5 moles of NaOH. Now that's great, I know that information, but how is that going to help me? I don't know, I can't just go into the cupboards in the chemistry room and grab 1.5 moles of NaOH. I can, however, weigh it out. So if I know how much NaOH I have in grams, I can easily take that and mix it into my solution. So I have to now figure out how many grams of NaOH are there in 1.5 moles of NaOH. And in order for me to do that, I would have to use molar mass. So I know that in 1 mole of NaOH, there are certain grams of that sodium hydroxide. So once you do your calculation, looking at your periodic table, you will find that there are 40 grams in 1 mole of sodium hydroxide. In other words, the molar mass of NaOH is 40 grams per mole. Now, having done this, this allows me to get the grams of NaOH, and my moles will cancel out, and 1.5 times 40 will give me 60 grams of NaOH. Now, what does this mean? Right? I've got 60 grams of NaOH. What do I do with the 60 grams of NaOH so that I can get to the concentration and volume that I need? So this is where a lab procedure comes in. So first of all, we have to start with the appropriate volumetric flask. We talked about volumetric flasks already, and we talked about that they come in different sizes, right? You can have 50 milliliters, 500 milliliters, 1 liter, 2 liter. Let's take a look at our question to see which one might be appropriate. They want us to create a 1 liter solution. So because they want us to create a 1 liter solution, it would be convenient for us to use a 1 liter volumetric flask. So I'm going to, again, attempt to draw a volumetric flask here. And I'm going to draw that line, that exact line that tells me that this fills up to 1 liter of my solution. Now, my first step here is to half fill this volumetric flask with distilled water. Now, I don't have to be exact about this, but I don't want to go all the way to the top either. So let's say about halfway, somewhere around there, you can just eyeball it, fill it with distilled water. Not water from the tap, but distilled water. Distilled water doesn't have any ions in it. If we use tap water, that might mess with the purity of our solution, right? So we want to just eyeball about halfway some distilled water into our volumetric flask. After we've done that, we want to add the appropriate mass of the solid. Now, this procedure is written in a very general way, but because we've done the calculation for the sodium hydroxide solution, we've calculated how much mass we need. In our situation here, we're talking about the 60 grams of NaOH. Now, if we were trying to find a different concentration or make a different concentration of NaOH, obviously this mass will be different. If we're trying to make a different concentration of calcium hydroxide, for example, again, that mass of that solid will be different. That's where that calculation is very, very important for us to do. After we've done that, so we've added the 60 grams of NaOH into here. I'm just going to write 60 grams. We've added that into there just with half the amount of distilled water. We want to wait for that solid to dissolve. So you shouldn't be able to see much of that solid left over at all. After it has dissolved, you want to add the remaining amount of distilled water. And remember, we have to stop at this line. So once you've filled most of this distilled water and you're getting close to that line, you want to be extremely careful. And that's where you might want to use something like a pipette or something that allows you to really control the amount of distilled water that goes into that volumetric flask without going over that line. If you go over that line, you'll have to start this entire process over because you do want to be accurate, right? We want to make a standard solution. We want to make a solution whose concentration we know for sure. Now, after you've gotten to that line, you've been very, very careful to add the distilled water all the way to the line. You've got the solid in there and it has dissolved. You want to put a stopper on it and invert it 3 times. This just allows us to mix the solute and all of that solvent all together to create our solution. Okay, that's pretty much it for the dissolving process in order to create a standard solution. The diluting one is pretty similar, but the calculations are slightly different. We've already done this, so maybe you can pause this video, try out this calculation, and play it when you want to take it up. So this question asks us to prepare a solution of 5, oh, that's a mistake. Make sure you correct that into your notes as well. 500 milliliters of NaOH with a concentration of 0.100 moles per liter from a 6.00 moles per liter solution of NaOH, right? So they're giving us what volume you want to end up with and what concentration you want to end up with and what solution to use, right? So I know that I want to end up, so V2 is going to be 500 milliliters or 0.500 liters of NaOH. The concentration that I want to end up with is 0.100 moles per liter. And we're all starting from a solution that has 6.00 moles per liter. So my C1 is going to be 6.00 moles per liter. This is what we call a stock solution, right? So we know the concentration of this particular solution, and we're going to take some of it. We don't know how much yet. We're going to take some of it in order to make this 500 milliliter 0.1 moles per liter solution. And this is what this question is. How much of that stock solution do I use? So V1 is equal to question mark. How much of this solution do I have to take in order to make this solution that I'm going to end up with? So in order to do our calculation, we have to use our dilution formula. C1V1 is equal to C2V2. I'm solving for V1, so I'm going to rearrange my equation so that C2V2 divided by C1, of course, because C1's being multiplied over here. When I take it over to the other side, it's got to be divided. So V1 is equal to, let me sub in all of these numbers, 0.100 moles per liter times V2, 0.500 liters, all divided by 6.00 moles per liter. And my moles per liter will cancel out, which leaves liters left over. So my V1 is going to be 8.33 times 10 to the power of negative 3 liters of that stock solution. So I need to grab this many liters of that stock solution in order to create this particular final solution. And I can also convert this to milliliters. That might be much more realistic for us when we're measuring this out into lab. Of course, if we're converting from liters to milliliters, we can make that conversion, which will end up with 8.33 milliliters of that stock solution. Again, the only reason I made that conversion is because it's much easier for us to measure out milliliters, especially to that scale, when we are making our solution. Okay, so how do we do this? This is pretty much the exact same procedure with a few differences. So let's see what volumetric flask we have to use, right? So we have to choose the appropriate volumetric flask. We're going to end up with a solution that has a volume of 500 milliliters. So why not? Let's use a 500 milliliter volumetric flask. And to that, again, just like we did in that previous procedure, you add a little bit of distilled water to the volumetric flask. And then instead of adding the appropriate amount of mass of the solid, we would add the appropriate volume of the stock solution. So this is what we measured out as 8.33 milliliters of this 6 molar solution. Okay, once we've done that, you add the remaining distilled water to the line without going over. We are very, very careful once we come close to that line that we're not overshooting. And then once we've done that, we just put the stopper on and invert a few times to allow for the solute and the solvent to mix. Okay, so that's how you would create standard solutions in a lab.